The last lesson in the unit is called completing the square, and it's an important thing to be able to do for the reasons we're going to see. So a quadratic function expressed in vertical form provides a lot of information about the parabola, the direction of the opening from A, the congruency from A, and the vertex. While the standard form gives us the first two properties, 1 and 2, by inspection. We look at A. It doesn't help us at all with finding the vertex, which is probably the most important piece of information of the parabola. So if we're given something in standard form, completing the square is an algebraic exercise that will give us the vertex form. So before we look at completing the square, let's look at where that would have started. Examples A and B are examples of perfect squares. X plus 3 to the power 2 is a perfect square because it's equal to x plus 3 plus x plus 3. Just think of 9. 9 is a perfect square because it's equal to 3 times 3. 16 is a perfect square, 4 times 4. 12 is not a perfect square because it's 3 times 4. So if we expanded out x plus 3, here's what we would get, which would look like this when you combine like terms. And if we looked at k minus 7 to the power 2, that's equal to k minus 7 times k minus 7, which would look like this. Again, a negative times a negative is positive, so there's our 7 squared, and we get k squared minus 14k plus 49. And perfect squares have a really nice relationship, and it looks like this. If we divide the middle coefficient by 2 and square, we get the constant. So negative 6 divided by 2 is 3, and 3 squared is 9. Again, it doesn't matter if it's positive or negative. We divide negative 14 by 2, we get negative 7. And when we square negative 7, we get positive 49. So perfect squares have this really nice characteristic. Now again, as we say right here, while the first and last terms are perfect squares, the middle term is 2 times the original in the binomial. And that's this idea. If we recognize this pattern by multiplying, then if we recognize what we have in a trinomial, then we can go backwards. So if we look at these, so what we're simply going to do for the next few minutes is just pound through a bunch of examples. We're going to go through this technique, and at the very end, if you haven't figured it out already, we're going to write down a recipe. But have a look at these two trinomials, and what I hope you recognize is these are not perfect squares. You can't take the square root of 20 nicely. You can't take the square root of 18 nicely. So just with the little idea up above, the other thing is if we divide 12 by 2 and square it, we get 36. And if we divide negative 10 by 2 and get negative 5 and square it, we get 25. So these are not perfect squares, but what we can do is we can do this technique called completing the square. And when you complete the square, you're going to put, this is going to change standard form to vertex form, and therefore we can figure out the vertex, which is probably the most important thing. Okay, so here's our technique. Step number 1, we're going to isolate the x's. Step number 2, we're going to factor out a leading coefficient if we have one, and in this case we don't, so we don't have to worry about that. And then we're going to look at this idea above. We're going to make a perfect square. And again, you can't just add stuff to an equation or a function. The only thing you can add to make it stay the same is 0. And that's what we're going to do. Creatively, what completing the square basically is creatively adding 0. So what we're going to do is we're only going to be concerned about the x terms. And what we're going to do is we're going to take we're going to divide the coefficient of the x term by 2, and we're going to square it, just like this idea above. So when we take half of 12, we get 6, and when we square it, we're going to get 36. So I'm just going to write 6 squared right now. So there's half the middle term squared. But if I left it like that, we wouldn't be talking about the same thing. So I have to counteract what I added with a subtraction. So again, here's this idea of making a perfect square, and there will be a perfect square, except we have to counteract what we've done, our addition with a subtraction. Now again, I want you to realize that this will always be an addition. It doesn't matter if the coefficient in front of x is positive or negative, because when you square any number, it always turns into positive. So when we do this add subtract idea, remember the key idea is we're trying to make a perfect square, and you're going to see why in a minute, but you can't just add something because that changes the function, that changes the question. You have to counteract whatever you add. So the next step we're going to do after we've taken half the middle term and squared it and then subtracted to make a net 0, we're going to pull out this last thing outside the brackets. Now later on, there's going to be one other thing we have to look at, but for right now, we're just going to pull it out. And when we do pull that out, we end up with x squared plus 12x plus 6 squared. And when we pull the negative 6 squared out, I'm actually going to square it, so we get negative 36. And now what we have right here is we have a perfect square. 36 is a perfect square, and x squared is a perfect square, and we have the pattern as we have above. So we can rewrite this to look like that, and when we add negative 36 and 12, or in 20, we get that. And what I want you to recognize is we have just changed standard form into vertex form, and our vertex is negative 6, comma, negative 16. So this is just a technique. It's a very, it's an important thing to be able to do, just like you learn how to factor in grade 10. And we're just going to practice and make sure. And again, there's something really valuable here. We get the coordinates of the vertex, and with a little bit of practice, this is really quite easy. So when we've already talked about this over here, this is not a perfect square because you can't take the square root of 18. So what we're going to do is we're going to isolate the x terms, and I'm just going to put a little bracket over here right now, and we're going to take half of the middle term and square it. So we take half of negative 10, which is negative 5, and when we square that, we get positive 25, and I'm just going to write it like this now. And again, we can't just add 25, we change the question, so we have to counteract that. Then what we're going to do is we're going to take out that last term, and again, it's always going to be negative, and again, I'm just going to take it out as a negative 25, and the brackets turn out to be a perfect square. And again, here's a little hint. Whatever this sign is, that's your sign right there. Just like whatever this sign is, that's your sign right here. And finally, we get negative 25 plus 18 is negative 7. And again, that is vertex form, and our vertex is 5, comma, negative 7. So again, technically, we are doing the same thing, and I just want to do a few more to make sure we understand, but along the way, we're going to add little wrinkles. So the first little wrinkle, well, the only little wrinkle really is when you have a coefficient in front of the x squared term. And in this case, we follow the same recipe. We isolate the x terms, but now the first thing we do is we factor out the coefficient. So in this one right here, we're going to factor out a 2 from both of these pieces, and what we get is x squared plus 7 over x, or plus 7x. Then we're going to complete the square. We're going to take half of the middle term, the x term, and square it. And again, it's always positive. So we're going to have 7 over 2 squared, and then we also have to add the opposite. Then what we're going to do is exactly the same as before. We're going to take this out, but when we take it out of the brackets, we have this leading coefficient, so we have to remember to multiply that as it comes out. So what happens is we have 2 bracket x squared plus 7x plus 7 over 2 squared. But then what we're going to do is we're going to move our negative. I don't care about the negative right now. I always know it's going to be negative unless the leading coefficient is negative. So we're going to take out 7 over 2 times 7 over 2, but we're also going to multiply by that leading term. So what we end up taking out is 49 over 2, which is negative. And we simply complete the square. So here's our 2 times x plus, remember, there's our plus, x plus 7 over 2 all squared, and 3 is equal to 6 over 2, so this turns out to be negative 55 over 2. So the vertex is negative 7 over 2, comma, negative 55 over 2. And if you want to absolutely double check that, get out your calculator and have a look. Okay, this one over here, again, for step number 1, isolate. Step number 2, factor out from the x terms. Step number 3, take half of the middle term and square it. Half of negative 12 is negative 6. Negative 6 times negative 6 is positive 36, but we have to counteract that. Next step is take out that extra thing we added. Take this out, but remember, we also have to remember that. So negative 6 squared is negative 36, and 5 times negative 36 is negative 180. And then finally, we complete the square and collect our like terms, and our vertex is going to be 6 comma negative 14. So we've gone from x squared by itself to a number in front of x squared, and we have to factor it out. Both those numbers are positive, but what happens when you have a negative in a fraction? And the answer is it doesn't matter. You do the exact same thing. You isolate your x terms, you factor out that leading coefficient. So we take out a negative 7 from x squared. We remove negative 7 from negative 42, which gives us positive 6. We take half of the middle term and square it, but we have to counteract that with a subtraction. We pull out that last term. And again, when we pull out the last term, negative 3 squared is negative 9, and we multiply it by negative 7, which is positive 63. And then finally, we complete the square. And the vertex is negative 3 comma 66. So it doesn't matter if it's a positive number in front, it doesn't matter if it's a negative number in front, it doesn't matter if it's a 1 in front, and in fact, it doesn't matter if it's a fraction in front, because we're going to do the exact same thing. We're going to isolate the x terms, we're going to factor out, and remember, when we factor, we're dividing. So negative 4 divided by 1/3 is negative 12. going to take half the middle term and square it. It's always positive. We have to add the negative. We're going to take out that last term, and we're going to remember the coefficient 1/3. So negative 6 squared is negative 36, and 1/3 of negative 36 is negative 12. And finally, we're going to complete the square. X minus 6 all squared minus 2. So our vertex is going to be 6 comma negative 2. So I know I went really quickly there, but it's because it's a recipe, and as long as you can practice it, you'll get good at it. So I'm going to finish the video, but here are those key things that I've been talking about